Okay, problem number 4. Write a polynomial in standard form that has zeros at negative 2i and 8. Well, what is that negative 2i telling me? It's telling me that I have a solution at x equals negative 2i. But if that is the case, then I must also have a solution at its conjugate, a positive 2i. And so that tells me I get two factors, x minus 2i and x plus 2i. And we also have a solution at 8, which is telling us we have an additional factor at x minus 8. But let's worry about that in a moment. Let's focus on this imaginary stuff first. Let's multiply these two binomials together. So x times x is an x squared. Negative 2i times positive 2i is a negative 4i squared. What did I just do with my foiling? I messed it up. Well, look, x times x is our x squared. X times positive 2i is a positive 2ix. But then we have to do x times negative 2i is a negative 2ix. They cancel because we're dealing with conjugates. So we're left with our first term squared, so x squared, and our last term squared, so 2i squared is 4i squared. Squaring the 2 and squaring the I, and we're subtracting it. First term squared minus last term squared when you multiply conjugates together. It's kind of like doing a difference of two squares backwards. Sweet! Okay, well, we can take this farther. X squared minus 4i squared is the same as negative 1, so really we get x squared plus 4 from just knowing that factor right there. We got a second factor, and so we got a quadratic, x squared plus 4. Now let's remember that we have that x minus 8, and now we can multiply out this x squared plus 4 into a standard form polynomial. So x times x squared is x cubed, x times 4 is a 4x, negative 8 times x is a negative 8x squared, negative 8 times 4 is a negative 32. So let's write this as a polynomial, y equals, and let's write it in the proper order. X cubed minus 8x squared plus 4x minus 32 should be our final answer. There are other appropriate answers, but that's the simplest one.